Hiya, hope you're all alright out there. It's Mr. Baker with another physics video, and today we're going to be answering the question, how fast do we have to throw an egg at a wall to cook it? We're looking at kinetic energy. So the question you never knew you need answering, how fast would you have to throw an egg at a wall to cook it? So, out of these two then, who's got the most kinetic energy, the dog or the cat? So the word kinetic comes from the Greek word kinesis, which means motion. Kinetic energy is the energy an object has because it is moving. All moving things have kinetic energy, but the amount of energy they have is not just dependent on how fast they're moving. What other factors affect the kinetic energy of a moving object, do you think? So our cat has obviously got more kinetic energy than the sleeping dog because the cat is moving. But it's also dependent on how heavy that moving object is. So we've got two factors that affect our kinetic energy. So, have you been listening? Could you finish off these two sentences? If you could, you might want to pause the video. So the first one here is kinetic energy is. If you think you can finish off that sentence, put this in your notes. So kinetic energy is the energy an object has because it's moving. And the factors that affect the kinetic energy of a moving object are, if you think you can answer that, then pause the video again. So the factors that affect the kinetic energy of a moving object are its speed and its mass. So how do we calculate kinetic energy? So the kinetic energy of an object can be calculated using this equation. So here we're using Ke for kinetic energy, and it equals half times the mass of the object times the speed squared. Okay, so we don't need to worry about velocity here because it doesn't matter if it's going in a positive direction or a negative direction, because when you square it, the negatives will just cancel out anyway, so it'll be a positive number. So it's just an amount, so it's not a vector, it's just a scalar quantity. So we can use speed, and if we use the symbols there, kinetic energy Ke equals half mv squared. So these are the quantities in their units. So mass is measured in kilograms, speed is measured in meters per second, and kinetic energy is measured in joules. And this is one of the equations that you need to learn. So like I said here, we use the symbol for V for speed because V stands for velocity, which is speed in a given direction. So we use V, and we use this quite commonly, V, to sort of mix and match between speed and velocity. So a car with a mass of 1,500 kilograms travels at a velocity of 20 meters per second. What is the kinetic energy of the car? You might want to have a go at this. If you do, then pause the video again and just have a go. Right, so I'm going to go through it now. I don't know if you had a go at it yourself, but let's have a look. So first thing we do is write down our equation. Kinetic energy equals half times mass times speed squared. Next thing we do is put in what we know. So we know that it's half, it starts off with half, times the mass, which is 1,500 kilograms, times the speed. This here we've got velocity, so it's the speed in a given direction, but it's the speed, which is 20, and that's squared. And so that equals 300,000 joules, or we could write that as 300 kilojoules, because a kilojoule equals 1,000 joules, just like a kilometre equals 1,000 meters. Right, so if you want to find the mass or the speed from the kinetic energy equation, you need to rearrange it, and here I've rearranged it for you. You might be happy with the maths and be able to rearrange it. It'd be useful for you to be able to do that. If you're not, then you might want to learn how to do that, or learn these specific equations here. I'm not going to go through it now, but I might go through it in another clip to show you how to do that. But if you want to know, if you want to find the mass, then it's 2 times kinetic energy divided by speed squared. And if you want to find the speed, it's the square root of all of 2 times kinetic energy divided by the mass. Right, so we have done these things. So this is what you should be able to do. You should be able to describe what kinetic energy is and how different potential energy stores can be transformed into it. And you can also recall and use, hopefully, the formula to find kinetic energy. And hopefully as well you have seen the different rearrangements of it, and you'll be able to do that and have a go at working out the speed and the mass if you're given all the other two things. Right, so we're answering this question then. How fast would you have to throw an egg at a wall to cook it? So let's say it takes about 1,000 joules to cook a 60-gram egg. I've done a little bit of Google research and this is what I found out. If all of the energy from the egg smacking the wall results in heat to cook it, then the kinetic energy must equal at least 1,000 joules. So let's say it's 1,000 joules and all of that energy is going into cooking the egg. So we know our equation, kinetic energy equals half times mass times speed squared. So 1,000 equals a half times 0.06, because 60 grams equals 0.06 kilograms, and that's times by our speed squared. So we rearrange the equation, and speed equals the square root of 2 times our kinetic energy divided by the mass, so 2 times 1,000 divided by 0.06, and so the speed equals 182.57 meters per second, which is 408 miles per hour. So if you consider that a baseball is thrown at about 45 meters per second, which is about 100 miles per hour, then we've got to throw an egg at a wall pretty fast in order to cook it. Okay, so that's been our lesson on kinetic energy. I've been Mr. Baker, and I will see you next time. Thanks very much.